it operates on a data source or a collection. So why I mentioned data source and collection different? Because collection in Java is an interface, and there are several data structures that fall within this. Okay, several, for example, list you call right, all sort of your stack queue, or all of that is still part of your collection. But map is also a data source, which is not a collection. Once you go and review that collections video, you will get to understand. Okay. Next, stream itself never provides storage for the data. This is very important understanding. In a stream, you cannot store the data. It provides you a common platform to pass through the data by making some transformations. That's it. That's the whole purpose of the stream. It cannot store the data. Clear? Now, what are the type of operations that we can perform along with the along with the data movement? We can do filtering, we can do sorting, or we can just do simple movement of the data. That's it. Next, a stream operation by itself does not modify the data source. So the stream operations that you are performing, it will not change the source from which it is pulling the data. So this is also very important. From whichever data source. So first thing we know that stream will work on a data source or a collection. It cannot store any data. Plus, it is also not, it will not modify the data from the source. And what are the other, right? What are the tasks that stream can perform? It can perform filtering, sorting. It can it can just simply move the data, transform from one type to another type. That's it. That's the role of stream. Clear so far? Now, let's talk about the stream API. Stream API, again, it defines several interfaces. The one of the base of it is java.util.stream. Okay, java.util.stream. Okay, sorry. One of the base packages, this is your package where the interfaces will be defined, but the interface is that is called as base stream. It takes two type parameter T as well as S. And if you see, the S extends itself. If you see, S extends itself. Okay, that's the recursive power of the stream. S extends itself, and that's why we are able to perform operations on each actions because of these nature of the declaration of this syntax. Now, base stream also extends auto-closable. It also extends auto-closable. What does this mean? This means that we can use it along with the try with resources. We can use along with try with resources. That's why. Now, what are the base stream interface? What are the methods that is declared within that? So if you see, because it is extending auto-closable, it will have close. Now, there is a method called isParallel. Now, each parallel, what it does is it checks and returns true if the stream is for parallel stream. Okay. Next, iterator, it will just simply return the iterator. So if you see on the stream also here, they gave some sort of iterator. Okay. Now, because you got the iterator, you will be able to convert it to collection as well, right? Very easily. Now, next thing. This is again on close what you want to do. So this is just a handler of that particular on close. Then a parallel. So this parallel method, once you invoke a parallel on any stream, it returns a new stream. Okay. It returns a new stream on which you operations that you do that will be performed on parallel. But if you see the return type of it, this is still S. So whether it is a parallel stream or it is a sequential stream, it is still, we are still able to denote by the same type parameter. Internally, it has a mechanism to know whether it is parallel or not. In fact, it is exposed to us as well that, okay, I can go and query on any blind stream is given. I can go and make a query on that particular stream that, hey, whether this is parallel or not. Simple. Now, another thing is sequential. Sequential as in it will return the sequential stream if you are calling a sequential method on a parallel stream. Okay. If you are calling sequential on a sequential stream, it will return itself. But if you have parallel streams, you are calling dot sequential, you will get the sequential version of it. Okay. Now, then it has something called a split rater. A split rater means you will get, consider it as multiple iterator. Simple. You will be able to iterate, right, in parallel. That's what a split iterator gives. Simple iterator, what it gives, you will be able to use simple iterator will return one single iterator in which you can traverse from, right, either from one side or this side. Simple. Okay. And then again, unordered. So what happens is stream keeps the property of the source. Okay. So keeps the property of the data that is lying on the source. What do we mean by this? We mean by this is if at your source data is sorted, then whatever operations that you are performing, even if you are performing some parallel operations, they will guarantee the order. They will guarantee the order. Any operations that you are performing over a stream where data is sorted, your data in the source is sorted, the parallel operations that will run, they will ensure that the result will also be sorted. That's the guarantee. But there are certain operations for which if we keep them in the ordered, or if we apply some of the actions keeping them sorted, that will slow up the operations. And for that matter, what we can do is we can call unordered method on the stream. We can call unordered method on the stream, and that will return the unordered stream. What it means, any parallel operations now I will perform on this unordered stream, it will not, it doesn't need to care about the order that is present at the source. So that's the difference. Okay. Got what's the difference between what's the meaning of unordered? Unordered will return the unordered stream because the stream's default property is if the data at the source is sorted, I'm gonna get the sorted output. But there are a lot of operations, intermediate operations I can do within the stream, which will slow up if sorting order needs to be preserved. I hope this should be clear.